Hi, welcome back to the session. In the first session, we have discussed about the firewall, some of the different attacks, and in the second session, we have discussed about different encryption techniques like symmetric key, asymmetric key. Later, we discussed about PKI, that is public key infrastructure, how trust relations are happening, what is this certificate, how this certificate exchange happened between client and server, etc. So in this session we will concentrate on SSL, that is secure socket layer. This secure socket layer is developed by Netscape for internet transactions. Whenever we wanted to transfer some important information or secure content over the internet, usually we are using this SSL protocol. This sits between network layer and the application layer like TCP/IP and HTTP. We will see the details how this will be used in the applications or while transferring the information or while accessing the websites. This encryption technique or SSL, it uses PKI, that is public key infrastructure, and symmetric key encryption technique. It uses digital signatures. We already discussed about digital signatures and what is the importance of digital signature or how the signature is verified. So briefly, there is digital signature is nothing but we are encrypting the message using private key and decrypting the message using the public key. That means it will guarantee that this message is sent by a particular or authenticated person. But usually in other encryption other than digital signature, we are encrypting the message using the public key but decrypting the message using the private key. In digital signature it is reverse, encryption private key, decryption public key. So there are many type of or many versions are available. SSL version 2, 3, TLS, that is nothing but transport level security. And another important thing what we have to understand is cipher suit. So during the SSL handshake, we will see that detail. During the SSL handshake between client and server, usually this information exchange will happen. That means both client and server should agree with common type of algorithms. What is this cipher suit contains? This cipher suit contains one thing is key exchange algorithm like RSA, DH, there is Diffie-Hellman. We will see that what is that Diffie-Hellman algorithm later. Next is encryption algorithm. What algorithm is used to encrypt the data or the information like DES, AES, AAAS, so many other algorithms for that. So this algorithm, what algorithm I am going to use, or both client and server has to agree with the common algorithm before actual message transmission. Next is checksum or hashing algorithm like SHA1, MD5, this type of. So these three are the important information we have to look in case of cipher suit. That is, cipher suit contains these three important information. For example, here cipher suit is nothing but triple GS encryption with 168-bit key and SHA1. MAC is nothing but message authentication code. We will see that. So as I told, this cipher suit is negotiated at the initial stage of the message transmission, that is called as a SSL handshake. Okay, how this SSL session will be established. So for example, here I am using a browser as a client. So browser will send a message to the server, that is called as a client hello. In case of SSL, we are saying it as a client hello. during the client hello, this client, for example here it's a browser is sending this cipher source. In the client hello, client is sending the cipher source. That means what are the algorithms, key generation algorithm, encryption algorithm, hashing algorithms, I know, or what are the algorithms supported at the client side is sent in the first step, that is client hello. So then what will happen is, when server receives that client hello, it will verify whether these type of algorithms are available with me or not, whether server is supporting that algorithm or not. Okay, multiple algorithms are supported now. Then what will happen? So server, what it will do is, it will select the strongest algorithm. For example, out of 5 algorithms, server is supporting some 3 algorithms. Out of 3 algorithms, server will choose, okay, out of 3, this is the strongest algorithm. Strongest algorithm is nothing but which is having the longest key and better encryption algorithm, key exchange algorithm, hashing algorithm. We will see that later in the hands-on session in maybe in next 3-4 slides. I will show you during the hands-on session how this will happen. So, but the thing is, server is selecting the strongest algorithm out of the available algorithm. So here both are agree with the common algorithm. Once they are agree with the common algorithm, then server will send a certificate, server certificates. Now this step is we already see in case of PKI, public key infrastructure. SSL also use the same logic, that is PKI logic. Now server is sending the certificate, client is verifying the certificate in the trusted certificate list or in the wallet. It will verify who is issued that certificate. In this case it is VeriSign, that is trusted third party. Once everything is fine, then it will send the random data. So this random data is used to generate the symmetric key or the session key. We will see how this session key or the symmetric key will generate in the later step. Okay. Once this is done, now everything is ready. That is, it has already authenticated the thing using the digital signature. Okay. Now session keys are generated. Now everything is fine. Okay. So now digital signature is verified, everything is fine. Next, they will generate the pre-master secret. Pre-master secret is exchanged between client and server. Then both will generate the separate master secret. This is a private. This is the private. So here onwards, once this pre-master secret of the session key, once master secret of the session key is generated, they are using this session key for encryption and decryption. Here onwards, it will not use that public key private key combination, because we have to encrypt using public key, then decrypt using private key. So for every message, if we have to do that, then it is a costly. That's why both client and server, they will generate a common key, that is called as a master secret. Here onwards, they will use a session key for encryption and decryption. Okay. So how this SSL session established? So when SSL, or how to verify whether my connection is secured or not. Okay. So I will show you this in hands-on session, but for time being, in any browser, if you see this one, first one, usually we are entering as HTTP. That HTTP is not a secure one. When this channel is established, SSL channel is established, then this will become HTTPS instead of HTTP. Along with that, you can see this log button. Along with that, you can see this padlock button. That means here onwards, this page is secure one. Okay. So usually this SSL uses the default port as 443. I will show you these things in detail. Yeah. In the previous slides or when we discuss about PKI, every time we discuss that only, or see, for example here we saw that only server is sending the certificate. Only server sends certificate. What about client? Why client is not sending the certificate? So in case of SSL or authentication mechanism, there are two types. One is server authentication mechanism, another one is mutual authentication. Rarely used is client authentication. So in this example what we are saying is this is a server authentication technique. That means client is authenticating the server, or server is get authenticated by server certificate. This is called as a server authentication. If client is sending the certificate, only client is sending the certificate and server is authenticating the client, then it is called as a client authentication mechanism. In some cases we need mutual authentication. That means both server has to send its certificate, client also has to send its certificate. Both are exchanging their certificates and get it verified at client as well as server side. This is called as a mutual authentication. In this slide we are seeing the same thing. In the previous step server sent the certificate, now client is sending the certificate and it is verified by the server. So if everything is fine, then they will go for the pre-master secret. That means they are exchanging the random number, digital signature, then they will generate the session key. Okay. So this type of thing is called as a mutual authentication. That means both client as well as server get authenticated by respective certificates. Okay. Another important thing is certificate revocation. Certificate revocation is important because we have to, for example, one employee left the company, then we have to revoke all the privileges associated with that employee. Similarly, if that certificate is expired or if that private key is get compromised, then we have to revoke that certificate. Okay. We have to revoke that certificate. This certificate revocation or this revoked certificate is maintained in certificate revocation list. That is called as a CRL, certificate revocation list. This certificate revocation list may be maintained in the LDAP. Certificate revocation list may be maintained in the LDAP or in the flat file. That is not an issue. Different mechanism. Which one is convenient, we can maintain. Either LDAP or flat file or some other mechanism. But important thing is, when certificate is get authenticated, when we receive the certificate, while verifying the certificate, always we have to check the certificate revocation list or the CRL, whether the certificate is revoked or not. Okay. That is the important thing. Next is certificate chaining. Certificate chaining is nothing but, as I told or mentioned in my previous session, we have to get the certificate from the third party. In our example, we use VeriSign. Similarly, we can get the certificate from the different certificate authority like Entrust, some other certification authority. Okay. So this certificate chaining is nothing but, in case of certification authority or when certificate is get issued, there are two important certificates. One is root certificate, another one is actual user certificate. In between this user and the root certificate, there may be a multiple intermediate certificate. There are multiple intermediate certificate. That means in between root certificate to user certificate, there may be a more than one or more than one intermediate certificate. That is called as a certificate chain. That is called as a certificate chain. For example, here we are having a Oracle root certificate and we are having the actual user certificate. Okay. In between we are having the multiple intermediate certificate. In this example, intermediate certification, this is the trusted root CA or the certification authority. Intermediate certification authority, for example, here in Australia we are having one of certification authority. In US we are having one CA, and UK we are having one CA. For example, for all the UK customers we are issuing the certificate using UK CA, for US using USA CA, etc. So in this case UK CA is generating the certificate for support certificate. Okay, for support CA. This support CA will generate the final, user certificate. These are all called as an intermediate certificate or the intermediate CA. This is root CA, this is actual user certificate. In between root CA and user certificate there are multiple intermediate CAs. This is called as a certificate chaining. Okay. Next important thing is this common secret. That is nothing but how we are generating the common secret or the session key. In this case I have taken how we can generate the common color without knowing each other. Okay. So for example, here Alice and Bob, they are having the common paint. Okay. This is exchanged over there. We will see actual example later. So these two known to both. This is public, but these two colors are secret. No way Bob or she don't know anything about these two colors. She is having her own secret color, Bob is having his own secret color. By combining these two colors, there is one color generated, and combining these two, one color is generated. Now they are exchanging these two, but these two are secret one, private. No way they are exchanging. Now they are exchanging these colors. Once again they are adding their own private colors and come up with the common color. Both are having the common color. This is nothing but a session key. Both are having the symmetric color or symmetric key now. Okay. So now we will see the example. Okay. Now client and server, they are having they wanted to generate a session key. So first what will happen is client will select some random number. This is a secret number. At the same time server also generate some random number, that is also secret. They are not exchanging that one. Now server is generating, both client and server, they are generating G of C. The C is private or the secret, mod P, G of S, mod P. G and P are public. Similarly here how they are exchanging in the previous slide, how they are know about this color. Okay. Similarly here this one G as well as P, these two numbers base for the modulus G and P are public. They are exchanging over this one. Here client is initially select this G and P, then it will send this to server. Then server will calculate this one G raised to S mod P. This S is server's secret key or the secret number, secret random number. It will generate a G of S mod P, then it will send it to client. Now client will generate G of C mod P, then send this to server. Now server is having G of C mod P and client is having G of S mod P. Now both are passing this information to a function, then they will generate a session key or the common key. Okay. So we will get better understanding or knowledge using actual example. Now client is selecting a random number P. It is usually a big prime number. In this case she is selecting a prime number 23 and G is 5, base for that modulus, that is G is 5. Now she is calculating what is that? A is equal to G of C mod P, that is 5 raised to 6 mod 23 and 8. Now she will send this number 8 to other side, Bob. At the same time, Bob will generate G of S mod P, that is S is a secret number for Bob, that is G of mod P. Here G is known, G and P known to both, that means 5 raised to 15 mod 23. So here B is equal to 19. So now Bob is sending this number 19 to Alex, other side. Now what will happen is they have to generate a common key or the secret key. Now A is sent to other side Bob, and Bob is sending this number 19 to her. Now what she will do is, using this number 19, she will calculate the or generate the secret key, that is nothing but B raised to C mod P. See, once again this C is secret for her. This is a secret number for her. Using that secret number, she will calculate B raised to C mod P, that is MS, that is secret, that is message secret, common secret is 2 now. At the same time, Bob, using his own secret number S, using this A and P, he will calculate this master secret, then it is 2. This is a simple Diffie-Hellman algorithm. So using this simple mathematics, they will generate the common secret without exchanging the without exchanging the private or the secret numbers G and C. Once this secret key is generated, SSL uses the secret number for further encryption, decryption or message transmission. Okay. So this is once again how this flow will happen between those two, client and server. Same thing whatever I explained in the previous slide. So this will show the flow, what are the numbers exchanged between those client and server. Okay. Now we will see some hands-on session. Okay. So I mentioned many things about certificate and this handshake, everything. So this is simple one. If here for this hands-on I have taken Oracle database and I have used that TCP/PS protocol, and I have taken the trace files or the log files. It is simple. If you use Oracle database and SQL Plus as a client, here this is the client and here is the server. So in the SQLnet Aurora, you have to enable these two parameters. Trace level server is equal to trace level server is equal to 16 and this one, and you have to mention the wallet location, that is trusted certificate location. In both server as well as client, you have to mention that one. Okay. As the first step in the handshake, so what will happen is cipher suit exchange. Okay. So as I mentioned, first client had to send a client hello. First, that is client has to send a client hello to the server along with the cipher suit. So here it is sending the client version, what type of SSL version it is using. Here it is a SSL v3. So this is the cipher suit whatever I mentioned in my previous slide. See, client is aware of these many algorithms: RSA with 3DES and SHA and hashing algorithm. These many cipher suit client knows. So client is sending this information to the server during the client hello. Now what will happen at the server side? Okay. See, once server receives this information, whatever client sends here, what I mentioned is server verifies all these algorithms, whether these algorithms are available or not. If yes, then it will select the strongest algorithm and send that information to the client. In this case, out of these algorithms, the server is selecting this TLS, that is transport level security. So key generation algorithm is RSA. As I mentioned in the cipher suite, three things are important. One is key generation algorithm, another is encryption algorithm, another one is hashing. So here it is a RSA key generation algorithm, encryption is 3DES and hashing is SHA. So server selected this is a strongest algorithm and it will send back to the client. So it will send back to the client. Okay. Once this send this one, then it is sending its own certificate. So this is server certificate. See here C is equal to, so this is the server's certificate. This is the server certificate, information about the certificate. It will send it to the client and it will say that server hello done. That means it is a message to the client saying, yes, I have done with my part now. I have sent whatever this cipher suite and I have sent my certificate. What will happen at the client side now? Now client has to select that cipher suite. Yes, okay, it has received this one. So both are agree with this common cipher suite and now client has to verify the server certificate. See, this is the certificate what server sent. So now here client receives this certificate and next step is it has to verify that certificate. Okay, so see here this will verify. So those details will happen at the back end. So important thing is now client receives the certificate and it has to verify that certificate. Once verification everything is done, now it is their duty to come up with the common secret, that is private key, session key. See, now what will happen is client key exchange. See, they will have a encrypted pre-master secret using diff-Hellman algorithm. So now client is sending that random number when it will select it, that big prime number as well as that base for the modulus. So it will send that information, that is called as a pre-master secret. That pre-master secret has to be sent to the server. So now client is sending that to the server. So now once server receives that pre-master secret, once this receive the pre-master secret, it will generate the master secret. Okay, so it will generate the master secret in this step. Now what server will send is, okay, now what server will do is, see here. So now it will create the master secret and it will send a change cipher spec to the client. That means I have created the session key. Here onwards I am using session key, not public key, private key pair. I am using the session key. So please use that session key here onwards for encryption and decryption. See here once again same thing happen for the client side. Client also send to the server saying that change cipher spec. That means I have generated the common secret private key. So I am using that key for message encryption here onwards. So both are generated the common key. So finish. So this is finish. Both client and server finish their steps. That means here secure communication channel is established between client and server. Now it guarantees that the communication channel whatever we are going to use is secure one. So in this way this SSL handshake is established or secure channel is established and certificate exchanges happen, pre-master secret is calculated. Okay. So hope you got idea about client and server, how they will establish the SSL session here. Okay. So next is, if I wanted to use a browser, then how to make sure that this is a secure one or not. Okay. For example, now I'm using. It is a very popular our Gmail thing. Okay, as I mentioned thing, first you have to check whether this is HTTP or HTTPS. If it is HTTPS, then it is a secured one. If it is a HTTP, then it is not a secured one. For example, here I will show you. For example, here simply we will go for one website. For example, okay, HDFC Bank. Okay, I will go to. Okay, please check this one. This is simply www.hdfcbank.com. This is a web page. Okay, usually this will use HTTP because this is a public one, nothing to encrypt or decrypt or hide, nothing to hide anything here. Okay, everything is open and it has to be public. Now, for example, in the HDFC Bank, now I will go for this net banking. Okay. Okay. For example, okay. If I go for net banking, writing now. Oh, sorry, I have clicked wrong one. So here, see, I will go for a net banking. Net banking. Until here, everything is unsecured one, but this net banking should be a secured one. This net banking should be a secured one. See, now you can see protocol used is HTTPS. Previously what will happen is, see, it is a simple web page, everything is HTTP. Now net banking, because here I am using my personal ID, password, everything. So it has to be exchanged between the browser, that is client, and the backend server. Okay. So we have to verify whether this is HTTP or HTTPS. Another thing is this padlock. Okay, here when I click on this one, see, you can see this one. When I click on this lock and connection, I can see the information. See here, what will say, your connection to net banking depends, okay, encrypted with 128-bit encryption key. 128-bit encryption key. It uses TLS, that is transport level security. What cybersuit it is using? It is RC4 128. It uses RC4 128 with MD5. Okay. So now you can, these are the cybersuit and these are the information. If you wanted to see the certificate information, see here. See, it is, as I mentioned in the certificate, one of the thing is it is show that to whom the certificate is issued and issued by, that is trusted CA, certification authority. In this case, this is issued to HDFC Bank and this is issued by the VeriSign. And what is the validity? This is the validity. And another important thing what I mentioned is certificate is containing the public key. Certificate contains the public key of the user. See here, signature algorithm, etc. for a, see, public key. This is the public key. See, whatever we are seeing here, 2048 bit, 2048. So whenever this length of the key increases, the strength of the algorithm, or it is more secure. See, this is the public key associated with this certificate. Okay, what is this certificate part? I told certificate chaining. See, VeriSign class 3. This is the intermediate CA. This is the user CA. This is the root certificate. This is the user certificate. In between there may be a intermediate certificate. In this way, we can verify whether my browser or whatever I am using is secured or not. Okay. Next thing is how we can verify the wallet or the content. Okay. There are many tools available. Like OpenSSL. It is a free and publicly available. You can use that one, and I will show that one later. Okay, I am using Oracle. So Oracle is having its own tool called as a Oracle wallet manager. See, if you install Oracle in your laptop or desktop, so go to this one, Oracle Home. So integrated management tool. See, this is the GUI tool. This is the GUI tool. This is a GUI tool. So I told this wallet is nothing but a secure, that means password protected certificate store. See, this is the wallet manager. All of the things. Okay, this is this is a wallet manager. Okay, if you wanted to create a new one, yes, you can create wallet password. As I told, you can create a wallet, but it is a password protected. Okay, you have to enter this one. Okay, I have given some password. Okay, you have to create a wallet type, standard one. Okay, then empty wallet has created. Do you want it to create a certificate request? Yes, certificate request is nothing but I have to send this information to the third party CA, VeriSign or somebody, to get a certificate. Common name, for example, here I am using common name is Girish. Okay, organization may be Oracle. Okay, organization, okay, unit Oracle DB, maybe. Organization is Oracle. Locality Bangalore, and the state is Karnataka. Country is India. Okay, country is India. Here key size whatever. See, these are the keys supported: 512, 1024, 2048, whatever. If you want to use port 096, whatever. So for example, I am using 1024. Okay. Certificate request is created. See, here this is the certificate request. As I mentioned in one of my session, we can have either base 64 or DER certificate. In this case, it is a base 64. So in this case, it is a base 64, and it is using the RSA key generation, and length is 1024. At the same, this is a certificate request. I have to send this certificate request to the third party, and I will get the actual user certificate. At the same time, so I can see another field called as a trusted certificate. Here I am seeing so many things. This is nothing but the server certificate. Here I am having some default certificates. Whenever you wanted to verify the server certificate, or when I get the certificate from the server, I have to verify those certificates with this trusted certificate. So this trusted certificate, for here I am having the multiple trusted certificates. When I get a response from the server while verifying or when authenticating the server, I have to verify those certificates with the trusted certificate store. I can store as many as trusted certificates here. See, when you click on this one, it will show you who is that user. See, here is one, and once again this is server number. See, key type, everything you can see. Okay, in this way I can create a new certificate request and send it to one, and as well as I can see here so many options are there. You can open, close, everything, and you can import the certificate, user certificate, trusted certificate. You can delete. You can manage your wallet as well as server using this tool. At the same time, I will show you, as I mentioned. Okay, I will close this one. No. At the same time, I mentioned another free software or the tool called as OpenSSL. Okay, if you, but default usually it will come up with your installation either Linux or Windows. Okay, if you Just enter this open SSL, it will show you. So if you click on or type help, see it will show what are the commands or what are the things I can do. I can create a certificate or certificate required, you can manage the wallet, whatever. So previously whatever I show is a GUI, that is GUI tool, Oracle Wallet Manager. This is totally a command line tool. For example, now same wallet, whatever I show with Wallet Manager, I wanted to dump or I wanted to view the content of that wallet. So what is the command? So here, okay, command is, I am already logged into OpenS. Okay, pkcs12 minus in. So in the I am having the file name called as this one. Okay, so once again I told this wallet is a password protected. Then I have to give the same password. See, this is the content of that wallet. Same thing whatever we use in the Oracle Wallet Manager or the GUI. See, it is having the multiple trusted certificate, everything. At the same time, another important thing what I mentioned in my earlier session is this wallet is contain the certificate, along with it is having the private key of that user, See here, this wallet contains the private key. This is the private key of that user. Okay, during handshake or encryption, whatever it is, we are never exchanging the wallet through the network. We are exchanging only certificate. The certificate contains only the public key. Certificate contains only the public key, whatever I showed here. Certificate contains only the public key. See here, this is the certificate, this is having only the public key, not private key. We are exchanging the certificate, not the wallet. So in this way, OpenSSL can also you can use to verify or managing your wallet or trusted certificate store. Okay. Yeah. So these are some hands-on thing or brief about how I can verify my network is secure or not, how to verify certificate, and how I can verify the wallet certificate using different tools, etc. Okay, now so we can conclude this session by saying the internet works only because we implicitly trust one another. It is very easy to exploit this trust. The same holds true for software. It is important to stay on top of the latest certificate or the security patches, everything. Okay. Hope you got some idea about what is this internet security, what is this PKI, what is this certificate, how to manage the wallet, SSL, and how this SSL works, etc., etc. Then I can say thanks.